In this video, we're going to look at an introduction to networks and networking for computer science. So first things first, what is a network? So a network is a connection of two or more devices in such a way that they can communicate data with one another. And there's lots of different networks and ways you can arrange a network. But what I usually say is a network is two or more devices connected together to share data and resources. So we've got a local area network. So there are local area networks and there are wide area networks. Now I'm going to cover them in later videos. For now we're going to look at local area networks, which is a collection of computers connected together within a small geographical area. So your school, an office, a building, your home, they're all local area networks. Now they can be arranged in a variety of different ways and they are called networking topologies. But LANs can be wired, wireless, or a combination of two. So you think about at home, you might have your Xbox and your TV plugged into the router, so that's a wired connection, but you may connect to your home network on your phone using Wi-Fi. So that is a combination of wired and wireless. So LANs tend to have three types of devices on the network. Connectivity devices, so things like your routers and the things that actually get you on the internet and your modems. You've got your clients and servers, so you might have a media server at home, for example, or a web server if you're hosting a website, and you've got all your devices that consume the data, so your TV, your Xbox, whatever's actually using the connection. And you've got transmission mediums, which essentially means how does the things get sent, so that is through cables or a wireless connection. Now we're going to take a look at each of the topologies, how you draw them, and some advantages and disadvantages. So first things first, we're going to look at the bus topology. So first things first, we need a nice big line around the middle, which is going to be called the main bus. Okay, so let's draw a line like that. Now what you need at both ends are two circles for each terminator. Apologies for my circles, and I'm just going to label them with a T for terminator. Okay, so the idea is you've got the main bus, so that's called the bus, and these are terminators. Okay, so the next thing you need is your actual devices. Now what's easiest is to just draw lines going off, just like that. It doesn't matter how many you've got really, and then just label them with a little circle, and then you might say that's a printer maybe. That can be a PC, and a PC. Now these are all just nodes. So you've got a terminator, you've got the main bus, and you've got your nodes. Now that is how you design it, that's how you should draw it. If you look at any diagram on the internet, you will see that it's pretty much the same as mine. You get some that don't have the terminators on both ends. You might be represented by a server, you might possibly have a server on there as well. Something like that. But it's the same thing. And the idea is that data is going to flow down the main bus, and it's going to go to each of these nodes. Okay? Now, the whole point of a terminator is it stops the data getting thrown back, so data won't go that way. Okay? You can leave that off. So data will flow downwards in this direction, but it won't go back, so it won't reflect, because that would mean it'd be like collisions and it just wouldn't work very well. So these terminators prevent what's called mirroring. Now the only last thing to say about the bus topology is that it's not a bad topology, but if this main area in the middle, this bus, the main rubber's not very good. If the main wire gets disconnected like this, then it means that the network will go down. If one of these PCs didn't have a connection like that, that PC there would not actually get any data, so this one wouldn't get anything. Okay, so it wouldn't be able to access the network, it wouldn't be connected. So if the main wire or the main bus gets disconnected, or if one of these wires gets disconnected, then it means that that computer won't be able to access the network, or the whole network will go down if the bus is broken or disconnected. Now, the next topology we're going to look at is the ring network. Now, I apologise in advance for how terrible my circle is going to be, but we start off with, nice and easy, a big circle. Okay, then all we do is we draw on our nodes, so just draw some circles. Now this could be a PC, this could be the printer, we might have a server and another PC. So this would be a wired connection. And then one other thing you should do is you should probably draw arrows like this. Now, what that does is that shows the direction of how your data goes. So the way a ring network works is each PC or each node is connected to two other things. So the printer is connected to both the server and the PC. This PC is connected to the server and the PC, and the data essentially travels through, going around in this case, an anti-clockwise direction. Now it can be clockwise, it doesn't actually matter, just need to show that it's going through in one direction. Now the reason it goes in one direction is a little bit like with the bus topology. You don't want that mirroring. You don't want data going backwards and forwards because it wouldn't work, there'd be collisions, it's not the best way. So nice and easy, nice clockwise direction or anti-clockwise direction, as long as it's going one way, not both. That's about it for ring topology. There's not much to talk about. This one is what everyone sort of refers to as the worst one because it's easy to spread viruses, but we'll look into more on that in a second. And the next one we'll look at is the star network. Now the star network is a little bit different. Now it's a little bit iffy because you see different examples, so I'll try my best to sort of use them all in my example. So we start off first with, let's make my pen black, something in the middle. Okay, now this could be a server, you see sometimes, or you see a switch, or a hub, or a router. It can be any of these. Best ones to go for, if I'm honest with you, is I'd always go for switch. But if they give you a specific example that doesn't have a switch, then you can't do that. Now that switch will be connected to something like a server. And then all of your nodes are connected to the switch. There you go. So you've got something in the middle connected to all the other nodes. I mean, sometimes you just see this. You just see something like that. It's absolutely fine. But again, you need to have a central point, and all the nodes, no matter what they are, all need to be connected to the central hub, server, switch, or router. And the last one we're going to talk about is the mesh network, which I don't think for CIE you actually have to know about mesh network, but it's a good one to know about in general. So this one is what the World Wide Web is based on. So the idea of the mesh is that you've got lots and lots of nodes dotted about all over the place. And now, instead of it being like one route, like a route or a bus or anything like that, each of these nodes is connected to multiple routes. Okay, they don't necessarily all have to be connected to each other, but there needs to be multiple ways. Now, the reason I say it's like what the internet's based on is that, say if you wanted to get from point A, we'll say we've got B, C, D, E, F, G and H. If I wanted to get there, I could go this way, or if maybe this this path was obstructed there, maybe. I could maybe instead go this way. So there's multiple routes I can take. Apologies, I should have gone like that. So it's quite a lot more efficient in terms of if something goes wrong, it has ways to get around it, which makes it a much more reliable network. So next I'm going to look at the advantages and disadvantages of the bus topology. So the advantages are that it's cheap to install, there's not a lot of cable, it's easy to install, just plugging in computers into a main sort of cable, it's nothing too difficult. It's easy to add more workstations, you just add them onto the bus, and it doesn't require ridiculous amounts of cable unlike some other topologies. However, the disadvantages are that if the main cable or the bus is damaged, the whole network will fail. And as more nodes are added to the network, it will slow down, it's got poor scaling. And every workstation sees all of the data on a network, which if you've got things that you don't want certain employees to see, then there's a security risk. Next we're going to look at the ring topology. So the advantages are it's a fast transmission, because it's going one way there's no data collisions, and as you're just plugging in one computer to two others, it's cheap and easy to set up. However, viruses can spread easily, and any cable or device that's faulty in the network will make the network fail. So if one computer is turned off or not working, the whole network's down. For the star topology, it's very reliable. If a computer goes down, it will still work, as long as that's not the actual switch that's gone down. And there are no data collisions because the switch is a smart device, which I'm going to cover in a moment, which will do all this managing for us. If it's a hub, still it's that middleman that deals with all the transmission of data between the different nodes. However, it costs a lot more to set up. Switches, I know in my last school I think the switch cost something around £15,000, so that's quite a lot of money. So you need to have that extra hardware, and you'll have to get a specialist to come and set it up because they are quite difficult. You need a network technician. It's not something you would set up at home unless you had prior understanding of how to do that. And then the mesh topology. The mesh can manage high levels of traffic. So you think about the internet, that's got lots and lots of people using it all the time. If one device goes down, it won't affect the whole network. Adding more devices won't disrupt the network. So say you unplug something, which is adding some more computers in, you just take an alternative route, and data can take multiple routes to its destinations. However, it costs even more on a star network. It's very, very expensive. Building and maintaining a mesh is very difficult, and lots of connections are redundant. If certain nodes don't get used a lot, you could argue that it's not as cost effective as others could be. So next we're going to look at some of the connectivity devices. So we've got a hub. Now a hub is a device that sits at the centre of a star network, and that is connected to lots of clients. Now the idea is that it's designed to transmit data it receives to all connected devices, even if the transmission contains addressing information in the form of a MAC. So what that means is, even if it's something that's directed specifically to one MAC address, one individual computer, it sends it to all the devices. So imagine you've got computers A, B, C and D, and A wants to communicate with D, so it connects to the hub. The hub then broadcasts that message to all connected devices. So if you didn't want B and C to get that message, they would still receive that. So it's what's not called a dumb device, or a stupid device, or not clever device, because it just relays the message to everybody. So that's really not that good. The way I sort of see it is a little bit like you want in Call of Duty, you want to kill one person and you throw a grenade into the room and kill everybody. It's not the best way of doing things if you're looking for one person, so you wouldn't do that. Okay, so it's a dumb device. So as you can see, a little example there, all of them would get all of those devices. So as we said, it leads them to being called a dumb device. However, it's much cheaper than a switch, but it's slower because everyone's getting the messages, so that the network's going to be a lot more congested, and it can only deal with one communication at a time, and it's a security risk as data is broadcast to all computers. Now next we've got switches, which is the modern alternative. So whereas a hub is dumb, a switch is smart. So again, it sits at the centre of the network, and in a switch network, the switch looks at the transmissions and looks at where it's going to go. The switch will then say, right, it's going to go to PCD. So it'll give it to D only, it won't give it to all the other devices. Now switches can also do extra things. It can check for errors. Some switches, a little bit like routers, can have firewalls involved and things like that. So they're widely available, they're a lot more secure, they're faster, they can handle lots of transmissions, but they're more expensive and harder to set up. You actually can have two types of switches. You've got a managed switch, where you manually have to set up how it works, and you've got an unmanaged switch, which is a little bit more automatic and autonomous, but it obviously can't do as many things as a manual one. As you can see here, data's going to the switch and then sent across looking for the MAC address of number 3. So next we're going to look at MAC addresses. So immediate access control, or MAC address, is a unique number that identifies a device. So each network rated device, so anything that can connect to the internet or connect to a network, has a MAC address, and that is assigned in the factory by the manufacturer and cannot be changed. They're 48 bits long and usually hexadecimal codes, so they'll have letters and numbers to represent the number of it. Now, MAC addresses can't be changed, they're made in the factory. Even a little wireless dongle will have a MAC address, your phones all have MAC addresses, your computers probably will, unless they don't have a network card, and your laptops and tablets definitely will. Now a little Q&A. So the advantages of a switch over a hub is that it's cheaper, faster, with greater security. Now, how MAC addresses are used in a network. Each device has a MAC address. When a communication is sent, the switch inspects the communication and reads the destination MAC address. It then forwards the data onto the appropriate port, which goes to that computer. How do switches discover the MAC addresses of connected devices? When a switch is turned on for the first time, it has a blank address table. The first time a device communicates on a port, the switch will inspect the communication and read from the address. It then associates that address with the port and stores it for later use. It then broadcasts the message and listens for the response and assigns a destination MAC to that port and stores it for later use. Now another device similar to a switch is a bridge. Now a bridge is a network device that allows you to connect two LANs together. So the LANs can be wired or wireless, or a combination of the two. A bridge only has two ports, one for each LAN. So like a switch, a bridge looks at the MAC address to determine whether the communication must be sent to its own LAN on the left or the other one on the right. So which LAN it needs to be sent to. So you can see here we've got a wireless LAN and a wired LAN, and this bridge has two ports which connects both the switches together, and they can share resources. It might be a case of connecting two classrooms or two offices. Or it might be one big room and you're connecting the wireless LAN to the wired LAN. So it's all connected, everyone's phones are connected, tablets, iPads, projectors, and all the workstation PCs and servers.